Welcome to this video where the small exercise involves calculating shaded regions. In the previous video on doing areas, and again you may need to refer to the other sheet that has the area formulas there. In the previous sheet we were looking at items such as this one where I had a figure such as that one or such as this one where I might divide the figure into two smaller figures and calculate the area of each one. We refer to that as composite areas. In this particular case, instead of doing adding, the focus, the keyword would be the word subtract. I'll show you an example of what I'm talking about. Let's say that I had, and hopefully I can get this to work out correctly on this drawing. Let's say that I have an object that's like this, and I'm not sure how I'm able to do this on the computer. This might be a little bit tricky. But let's say I have an object like this one, and I only want to find the area of this part right here. What I could do is I could take the area of the entire figure, and if I cut out the part, again this may mess up on me, if I cut out that part right there, what I end up getting is just these little sections right here in the drawing right below it, which might be a little bit easier to look at. And again, this is very hard to do visually on the computer. I can do this better face to face with you. If I were to take this figure, I'll raise this on the screen just in case the video is not showing it to you. If I'm looking at this larger square like this, if I take this larger square, find that area, that gives me the area of the great big square. I'm not talking about the little guy inside, but if I were to go in and cut out this section right here, if I were to cut that out, I end up with just like the sidewalk that surrounds it. Think of that being like a common area, like a pool, since it's summertime during this video, and I'm cutting out the pool area and I'm just getting that little walkway around it. So if I take that entire blue figure and cut out this part, I end up with the shaded area. If it makes it easier for you individually, think subtraction. That is the key word, the word subtract. What you want to do when you have a shaded area like this is think in terms of big, subtract little. And that probably will help you out. You're going to find the area of the big figure and then find the area of the little figure inside that you want to take away and subtract those answers. For example, in this figure right here, pardon me while I erase this computer information to make it easier for you. If I want to calculate the area of this shaded figure right here, just the shaded part, and there's your key word, you want to think of that great big 4 centimeter by 4 centimeter rectangle. If I were to take this guy right here and find the area of it, you notice that it's 4 in width and 4 in length, so 4 times 4 is going to be 16. That is the area of the great big figure. That's the area of everything, the whole entire figure, all of it. Now if I want to get just the sidewalk part, the gray area, the shaded area, I'll look at this little rectangle or square, which is right here. That one is 2 centimeters across and 2 down. So if I multiply 2 times 2, I get 4. I'm purposely removing the units right now. So again, the area of the big square is 16 square centimeters. The area of the little one is 4 square centimeters. And again, like I said, you want big, which is this one, and little, which is this one, and subtract big, take away little. In other words, I'm going to take 16, subtract 4, and that's going to give me the area of the shaded region, which will be 12 square centimeters. Hopefully that helps out. Every single one of these works the same way. We look at example 2 down here and we're going, oh my gosh, that looks more complicated because it's got these little curvy sections inside the figure. But again, if you think big minus little, you'll be okay. I'm erasing this so it will avoid confusion for those who are very highly visual and may be confused very easily. To calculate this area, I'm going to look at this big square right here, and notice that it's 10 inches across and 10 inches down. Even though I didn't write it there, it's a square. If I calculate that area, that's the whole thing, every bit of it. That's going to be 10 times 10, which will be 100. In this case, they're inches, so it's going to be 100 square inches, which I wrote right there. Now, if I want to find out that shaded area, I'm going to subtract the part that's in white. So what I'm going to do is I'm going to take away this circle right here. And somebody might say, well, I don't have the dimensions for that circle. How in the world do I calculate that circle? Well, here's the deal. I know that across right here, or across right here, is 10 inches. No matter where I go in that circle, in that square rather, from one end to the other, it's always going to be 10 inches. The area of the circle is 1/2, and you have to use your other sheet for that, times pi times the radius squared. The radius is this little red mark right here. In fact, I'm going to purposely rewrite this in red color to see if this will help out those of you who again need the visual. Here's the radius right here. It's halfway across, and if I go halfway across, half of 10 is going to be 5. So that radius is 5. So to get the circle area, I multiply 1/2, or on the calculator, 1 divided by 2, times pi. Pi is equal to 3.14, which I've mentioned before, times 5, which is the radius, and then I square that, exponent 2. And that's what I've written right here. I end up getting, if you do the math on here, you end up getting, this is 25, and if you do the math, you end up with 78.5 square inches. Now again, you think big, or rather, sorry about that, you think big, subtract little. Okay? And the area has to be positive. It can't be negative. I do this every time with Windows 8. I apologize profusely for this screen acting up. Excuse me. Alright, big subtract little. The big one, if you recall, in blue, was 100 square inches. Again, I'm changing color so the color scheme matches up for you. The little one was 78.5 square inches. If I subtract those two numbers, I'll end up getting, and just do it on the calculator, which is fine, you end up getting, and that is an error on my sheet, it should be 21.5, not 22.5. That is a mistake. 21.5 square inches for the area of the shaded region. I hope this helps out. Again, rewind the video if you have questions, ask the instructor. Now if I want to try this exercise right here, if I want to find the area of this shaded region, again, here's what I would do. I would take the big rectangle and find the dimensions of those, subtract the area of this one. Now you might have to do some figuring to get these numbers. Don't just use 4, 30, 8, and 15 just because they're staring you in the face. You may have to do some thinking here. But again, think big minus little. In the same situation for the other exercise, very similar to what we had with the circle a minute ago, you're thinking the big square right here, subtract the circle. Now I don't have the radius in there, but remember, halfway across, you know the whole thing's 16, so you should be able to figure out what this one is. If you have any questions about this exercise, please contact me or get with a friend or rewind the video and replay it.